Okay, welcome to 6-4 Algebra 2. This is where we're going to take exponential functions and we're going to put a little value in here by the exponent. We just got a C in the formula, and we're going to see what changing that C, how it affects the graph and the outcomes. So I want you to copy this in your notes. Just make a template of these. Preferably put them on graph paper. And then what I want you to do is I want you to go to, write it down here, I don't think I put it on a board, Desmos.com/calculator. And in there, I want you to enter each of these equations and watch what the graph does. Then I also want you to take a graphing calculator and enter this into the graphing calculator and give me the answers here and reason how it's working. If you can't do this by hand, by the way, then we need to work on that in class. Okay? So make sure to bring it up during a Q&A. Oh, there's the Desmos.com calculator. Here's the other thing I want you to do in that calculator. I want you to compare this graph with this graph, this graph with that graph, this graph with this graph, and then I want you to compare these graphs. So write all those down, go compare them, draw a little sketch of them, and then look back at the bases and what's happening here and explain why they are what they are. Okay? Explain how they relate. Okay, so here's one more thing that I have you do in this little unit, is find two different equations for the graph. So just like we've learned in the previous two units, to find the A, it's the distance to the asymptote from your y-intercept, which equals 1. Okay? Your B, we plug in the point. We've got a point here of 1, 4. So we plug it into the equation. Our y value is 4 equals A is 1 times B to the first. Well, we divide by 1, we get 4 equals B to the first power. What would B have to be? I hope you're saying B has to be 4, because 4 to the first power is equal to 4. So, now we can write that equation as y equals 4 to the x. Now, the next thing they're asking you to do in this unit is to write that in another form. Change the base so that it's still equal to 4. Well, what other ways could you write 4 using exponents? If you're saying, well, 4 is equal to 2 times 2, so it could be 2 squared, that would be a great way to do it. Y equals 2 squared to the x. Now, somebody else might say, oh, I know another way to write 4. I could write 1/4 to the negative first. Absolutely right. You guys are awesome. So we could write it as 1/4 to the negative x. So that's what we're doing in these. We're just trying to think of a variety of ways that we could be writing the same thing. Now, growth and decay factor. As you saw in the previous unit, it's 100% plus the rate if it's a growth factor, 100% minus the rate if it's a decay factor. So, that is, you know what, I'm thinking this board might have come. No, I think it is on the right one. Okay, so this is where we're going to use some of these exponential functions. Is the money is compounded in times per year. Let's say it's quarterly or semi-annually or monthly. Then what would happen is we would take that 100% and we would take the rate and divide it by the number of times that it's compounded and then raise it to that same power. So an effective rate is trying to figure out how to get just this that's being being increased to the 100% alone. So we take the 1 plus all the rate increases raised to the power, and then we subtract 1. That'll give us our effective rate of what's actually happening to our money. Okay? Interest earned in 1 year as a result of a compounding interest in time. Okay? So, now we have a problem here. I know these seem kind of disjointed. I'm sorry, it's my fault. I didn't review the notes. I forgot that we were going here next after the change of base. But this is like your base. This is your B value in your money problems that we've been doing. And so we're changing the base slightly here. Okay? So we have Bank of America at 2.5% and Great Basin at 2.48% compounded monthly. This one's compounded quarterly. So if we look at the effective rate, you would take the 1 plus the 0.025, it's compounded quarterly, divided by 4, raised to the 4. Now this is just for 1 year, so we just 4 times 1. Now we take that, and we calculate it, subtract 1, and we get 0.02524. Okay? Now, we do the same thing for Great Basin, the 1 plus the 0.0248 over 12 raised to the 12, and then we subtract 1 from that, and we get 0.02508. So you can see, you can't just look at the percents here. It really is dependent upon how often they're compounded that can make a difference. This one came very close to being equal to that one, but this one is still a better deal. So the amount that would have in 5 years obviously would go with the better effective rate. And so now we just plug it back into our equation, and we take the principal amount that we start with, 850, and we're going to go for 5 years, so we raise it to the time of 5 years. And we just put that in the calculator and calculate out what our principal amount will be in 5 years, and there's what you get. I would suggest grabbing a graphing calculator, make sure you understand how to plug it in there, do it, and make sure you get this answer. You'll have problems similar to this in class. Okay, we'll see you there.